All right, chemists, here's another example of your box method. So this problem, I want to know how many grams of sodium chloride are required to produce 36.12 grams of chlorine gas. So I already wrote the balanced equation up here for you because I figured you guys can do that pretty well already. I made my box already. This time I only have 3 columns because I have 1 reactant and 2 products. So this is an example of a decomposition reaction. Remember, you have a more complex reactant, usually just one, splitting into different parts. So this case we have 2 products here. And they're a lot simpler than the reactant. The reactant, you have a compound, the products are 2 elements. Okay? So that's why I have 3 columns here. So in this problem, I'm looking for the amount of grams of NaCl. So my box I want to circle here is this one. This is the amount of grams, here's grams, of sodium chloride right here above this column here. Again, make sure your reactants and products are each above a column. Grams, molar mass, and moles are each of your rows. And then you want to circle what you're trying to find, and then put in the information you know. So the information I have here is 36.12 grams of chlorine gas. So I start with 36.12 grams of chlorine gas. I know the molar mass of chlorine gas because chlorine has a mass of 35.15 by itself, and I've got 2 atoms of chlorine, Cl2. So my molar mass of chlorine is 70.90 grams per mole. My molar mass I'm going to fill in here of NaCl. Na has a mass of 22.99, and Cl has a mass of 35.45. So when you add those together, I'm just going to say that sodium's 23 for simplicity just for this problem. Typically in these problems you want to be pretty accurate, watching at least relative number of sig figs, but I'm not looking for exact to the decimal point. Usually you're going to get a pretty close answer. So we'll just say 23 plus 35.45, which is going to give us 58.45. And that's again grams per mole. Sometimes I abbreviate mole, M-O-L. It's just the same thing, it's just a little bit less to write. And grams, of course, abbreviated G, remember that from physical science. So this is everything I know. I'm going to cross out this middle box, because like in the last problem, we don't really care too much about anything with sodium. We're only worried about the chloride and the sodium chloride here. So what I want to do first is start where my information started, so right here. And we're going to go down these boxes and then back up to get to our final answer. So you got to go down and back up, or down and back up, one way or the other to get to your final answer. Or I guess sometimes you can go up and back down. Either way, just make sure if you're going down, you're dividing. So first thing I want to do is divide 36.12 divided by 70.9. 36.12 divided by 70.9, and I'm going to get 0.509 moles. Okay, so that's how many moles of chloride gas I need to be producing. Now I need to bring this back to here, and again I'm going to show you a quick simple dimensional analysis just to double check, but I'm thinking we're going to want to do times 2 here. But let's double check it, because we're going from a mole ratio of 1 to 2. So if I have 0.509 moles of chlorine gas times 1 mole Cl2, ratio is 1 and 2, so 2 moles of NaCl, 0.509 times 2 over 1, so times 2, so we were right. So I'm going to multiply that by 2, get 1.019 moles over here. So that's how many moles are required to make this kind of amount that we want to get of chloride. and then we're going to go back up. So down was divide, D and D, down divide, up is multiply. So now we need to multiply. So we got that 1.019 multiplied by that 58.45. 59.55 is our final answer. Okay, so 59.55 grams, 59.55 grams of NaCl, sodium chloride, are required to produce 36.12 grams of chloride gas. So this is really important to scientists because when we're doing an experiment, when you're all doing experiments, you need to know how much reactant you might need to produce a certain amount of product. So, for example, when I did research at the University of Minnesota, I needed to create a certain amount of product so that I could use it and try different things with it. So I was doing a lot of organic chemistry research, but this kind of stuff was still important. So let's say I wanted to get about 100 grams of product. I would need to do some kind of stoichiometry problem like this. So it would be more like how many grams are required to produce 100 grams of Cl2. And I would have to work this way and figure out how much reactant I would need and figure out what do I need to put into this reaction to get out what I want from it. So this is important every day in chemistry labs. And it's a good skill to have, and this box method makes it really easy. So I hope that makes sense and it's easy, and I would invite you to try it and do a lot of practice problems and just do your best, and I think it'll be easy and you'll be really good at it.